Hi, this is Patel. In this lecture, we are going to look at the statically determinate structures and indeterminate structures. So, we have seen so many examples of the statically determinate structure. The determinate structures are the structure which can be calculated using the basic formulas which we have seen in the previous lectures. And the indeterminate structures are a little bit different from that. And we are going to look both of them in this particular lecture. So, we will see first the determinate structure, and in the indeterminate structure, we are going to see the difference between them. So, let's get started with the first slide, which is nothing but the example based on the determinate structure. So, you can see the given data of the example over here, and the given data says that a load of 2000 kilonewton is applied on the short concrete column of 500 mm. So there is a short concrete column. We all know that the column is the elementary member of any building, which is the structural member. This structural member is made up of the two different materials. The first one is the concrete and the second one is the steel bars which we insert inside the column to increase its strength or to strengthen it. So we are going to look at both the material and let's see how this given data gives us the better information. So the concrete column is 500 by 500 mm, which gives us the cross section area of the column. Here it says that 500 by 500 mm, which means that the cross section area of the column is having the side of 500 and 500 mm, which means the shape of the cross section is square. Reinforced with 4 number of 10 mm diameter steel bars. As I said, the column contains 4 number of steel bars. Each is having the diameter of 10 mm, which means if you cut the steel bar, you will get the cross section as the circular, and the circle is having the diameter of 10 mm. Now, what we need to do is to find the stresses in a concrete and steel. So we need to find out the stresses in each part. So whether it is a concrete material or a steel material. Take the value of E for steel as a 2.1 into 10 raised to 5 Newton per mm square. And for the concrete it is given as a 1.4 into 10 raised to 4 Newton per mm square. So this is the given data. Now we can make a figure like this, where you can see the dimensions is 500 mm and 500 mm on both the sides, which is the square cross section. It is having 4 number of steel bars in each corner, each having 10 mm diameter. So this is the basic cross section area of the steel concrete column. So we need to calculate stresses in each material, so that we have to calculate the area of each material first. So in order to calculate the area of a steel, we know that the 10 mm diameter is the diameter of one steel bar, but there are 4 number of steel bar, and that is why we are going to multiply the area with 4. So as you can see in this area, 4 into pi by 4 d square, and the diameter is 10. That's why instead of d square we have written 10 square. If you calculate, then you will get the answer as a 314.5 mm square. Make sure all the dimensions are in mm, so that you will get your final unit as a mm square. Now we are going to calculate the gross area. Now what is gross area? It is the area of the entire cross section of the column. It is not a particular area of the concrete or steel. We are calculating the gross area. What is the gross area? The entire square. So if you want to calculate the square area, then you will see that 500 by 500 is the gross area. The 25 into 10 raised to 4 mm square is your final answer for the gross area. Now if you want to calculate the area of the concrete material only, what we are going to do? We are going to subtract the steel bar areas from the entire gross areas. This is what we are going to do. So in order to calculate the concrete area, you can see that we are subtracting the steel area from the gross area. This is how we are going to calculate the concrete material area. P is given as a 2000 kilonewton. So 2000 into 10 raised to 3 Newton. Now if you look at the basic method to calculate this type of the example is nothing but the strain in one material is equals to strain in another material. So here in this case, strain in steel must be equals to strain in concrete. So if you want to put the value of strain, then you can write the strain as stress upon Young's modulus, which is the basic formula of the Hooke's law. So from the Hooke's law, we have written there sigma s upon epsilon s. Similarly, sigma c upon epsilon c. So we need to calculate the stress value, and for that we have to convert it in terms of the stresses only. So we have inserted the value of Young's modulus, which is given in the given data. If you subtract it using the calculator, you will get the relation between both the stresses as sigma s equals to 15 times sigma c. So this is our relation number 1. You can also write it as equation number 1. Now we are going to use another equation, that is the total force is divided into the two material like this. So total force is nothing but the P. Force carried by steel material is PS and force carried by copper material is PC. So both the material carries some amount of the force, and the summation of both the material forces is total force which is applied on the column. So the total force which is applied on the column is nothing but 2000 kilonewton. So we have written over here P equals to PS plus PC. Instead of P, we can write sigma S into AS and sigma C into AC. We are going to use this equation again so that you guys can relate those particular equation like this. This is the similar equation we have seen in the previous slide. So what we are going to do, we are going to insert the values and relation that we have obtained in the previous slide. What we have obtained, that we know that P is 2000 kilonewton. Sigma S can be written as 15 times sigma C. We know the area of a steel material. We know the area of concrete material. So if you look at the particular this situation, then you will see in this entire equations, the only one unknown remaining is nothing but sigma C. So if you take sigma C as a common and make it as a subject, then you will get the final answer of sigma C as 7.86 Newton per mm square. Put this value in the equation number 1, then you will get the answer of sigma S as 117.9 Newton per mm square. So this is how we have calculated the stresses for each material. And now we complete our example over here. What we are going to do next is to calculate the example of indeterminate structures. How indeterminate structures can be identified. So first of all, we need to look at the figure of that indeterminate structure. If you look at the figure, you will see that there is restrictions provided on the both ends. Restriction, or we can say that the supports are provided on the both ends. Each support has its own support reaction, and that's why you will get two more forces on the ends. First of all, let's read out the given data which is provided in this particular example. A compound bar ACB of 50 mm diameter. So the diameter of the entire bar is 50 mm. There is no change in the diameter throughout the length. With the right part CB of aluminium of length 500 mm. So the right part is made up of the aluminium, which is mentioned over here in the figure also. And its length is 500 mm. The left part is mild steel with the length of 300 mm. So the left part is mild steel with the 300 mm length, is rigidly clamped at the both ends A and B. So as you can see, both ends can be seen, A and B are rigidly clamped. It is subjected to 100 kilonewton force at the C point. So 100 kilonewton is applied here at the point C. Towards the right, find the stresses in each part, take ES and EA as given in the data. Whenever you solve this type of examples, you will see that there is a reaction in this direction and there is a reaction in this direction also. So, whenever these two reactions are given, you will not be able to calculate the value of each reaction to calculate the value of stresses. So, these are the example where you will see that the values are not calculatable, or we can say that you cannot calculate the values directly. So, what we are going to do, we are going to use two different relations, and from those relations we are going to calculate this type of examples. So first of all, we have divided the entire figure into the two parts. So the first part is the part where you will see the only mild steel material. So the mild steel material carries the reaction in this direction. That's why we have mentioned over here this direction. And the reaction of this reaction is in opposite direction. So both the forces must be equal and opposite, which is represented in the given figure. On the aluminum part, reaction direction is this, which is represented in the figure like this, and opposite direction force is represented here. What we are going to do now, we are going to calculate the area. Area of steel and aluminum, both is of the same diameter. That's why pi by 4 d square will give us the area of both the material. Now if you calculate it, then it is 1963.49 mm square. We list out the given data and we further use two relations which I was mentioning, and the first relation is this, that the reaction in the first part and second part, which is aluminum, summation of both the reaction must be equals to 100 kilonewton, which can be also seen from the previous slide that reactions are in the opposite direction of the given force. So if you just simplify that the right hand side force equals to left hand side force, then also you will get this relation. So this is the basic logic, and based on that particular logic we have used this relation number 1. So this is our first step to calculate this type of our example. So and the second step is nothing but the elongation of MS bar is the contraction of the aluminum bar. Now, how we concluded into this particular relation? We know that both the ends of the bar are fixed. You cannot contract them or elongate them. So what will happen? If first material is trying to get elongated, it will have to contract the second material. So whatever the elongation of first material is there, the same contraction will be there of the second material. So that's why we have taken that logic in order to solve this type of example. So particularly, elongation of the MS bar is the contraction of the aluminum bar. This is our second relation to solve this type of example. So what is elongation? It is nothing but delta L. And what is the formula to calculate the delta L? PL upon AE. So we know that formula, apply it for the steel and aluminum, put all the values except PS and PA. Everything is given. For example, L is given, area we have calculated, we know the value of Young's modulus which is inserted into this equation. So from this equation you will get the relation between PS and PA. Now we have two different equations, equation number 1 and equation number 2. Put the value of equation number 2 into the equation number 1 and you will get the answer of PA. From the answer of PA, you will get the answer of PS also. We have taken that the contraction of aluminum. So aluminum, it is getting compressed. That's why the nature of PS is compressive, and MS is getting elongated. That's why the nature of PS is tensile. If you put both these forces into the basic formula of the stress, then stress is nothing but the force upon area. We know the area for both the material is the same, and calculate it, then you will get the final answer as the 42.27 Newton per mm square. Similarly, you will get the answer for the aluminum material as 8.65 Newton per mm square. So this is how we are going to calculate the example of indeterminate structures. Indeterminate structures are not so difficult. Only what you have to do is to remember only two steps. Step number one is the summation of forces equals to the given force. Step number two is elongation of first material is contraction of another material. This is how we are going to calculate our example. So we conclude our lecture over here. Thank you.